Ok. Hôm trước thì bạn Hoàng Văn Đạt bạn có hỏi là quy định cộng điểm quá trình như thế nào. Thì cộng điểm quá trình này thì chỉ có là các bạn vì một số lý do nào đấy mà các bạn trả lời một vài câu hỏi mà tôi thấy nó thú vị thì tôi sẽ cho cộng điểm thôi. Còn nhìn chung quá trình cái cộng điểm quá trình nó cũng không có nhiều lắm. Chủ yếu là sẽ dựa vào cái bài thi giữa kỳ và lấy cái bài thi đó làm mốc. Đa phần thì là trừ nhiều hơn là cộng. Nhưng mà điểm thi giữa kỳ thì nhìn chung rất là cao, các bạn cũng không phải lo lắng lắm nha. Ok. So last week we already go to this slide, right? So everybody can see the share screen. Mọi người có nhìn thấy cái màn hình mình chia sẻ không nhỉ?
Yes, teacher. Có.
Okay, thank you. So last week we finished in this slide. So I already introduced some tool to modeling the logic control system, like Boolean algebra, finite state machine, state charts, graph sets, and Petri nets. So for the finite state machine and state chart, we will not consider in this section, in this subjects. For the Petri net, we don't have much time to study about the Petri net. So in order to give you knowledge so that you can work in the industry more efficiently, I think two tools is enough for you. It's a Boolean algebra and graph set, and then I will introduce this tool in this subject. So first we will study about the Boolean algebra. Actually, the Boolean algebra is very popular, and I'm sure that all of you already know it. But I would like to review the Boolean algebra, and then if during this revisions, if you have any questions or comments, then we can share the idea with each other. So first we have the definition of the logic variable. So as I mentioned some examples in last week, if some events or some phenomena or some variable that have only two values, like good or bad or right or wrong or close or open, then we can consider to present them as a logic variable. Of course, when we try to present them as logic variable, we try to using some mathematical tool like a Boolean algebra to to present or to solve or to synthesize or to develop or to design something related to the logical function. So to more clearly, usually people represent a logic variables using 0 and 1. But remember, in these situations, in the Boolean algebra, 0 and 1 is different from the ordinary algebra. Okay, so it's like a symbol. Because Mr. Boole choose 0 and 1, so all the people use 0 and 1 for the logic variable, but actually you can use anything just with the two symbol to be the logic variable. So please remember, in this subject, 0 and 1 is a logic representation. It's not the ordinary algebra. So there are some arithmetic, logical arithmetic that will have the different result with the ordinary algebra. Okay. So for the normally ordinary algebras, people use like a nature number to be the set, and they build the ordinary algebra. But for Boolean algebra, they use a set just only two value, 0 and 1, and then they build all the calculations around this set. So this is a normal way to develop or to build up a theoretical part in mathematics. Okay, so for the logic variable, please remember the logic variable have only two values, 0 and 1, and 0 or 1 is just the symbol. And then we have to define some functions from using these two symbols. Okay, so next, about the logical functions. Logical function is used to present the relationship among the logical variable. Okay, so actually the function is the relations. Okay, so we have two conditions in order to define a function is a logical function. The first condition is all the variable of these functions must be logical variable. Okay, so this is the first. Okay, wait for a moment. I choose a pointer. Okay, pointer, where is the pointer? So this is the first condition. A function is called the logical function if all its variable is logical variable. So it's 0, 1 here is the logical symbol. So all the arguments, the variable is the logical variables, and the value of the functions, okay, also a logical value. So this is the two conditions. First, the variable must be logical variable, and second, the result, the value of the functions, also logical function. It means that the logical function is a relationship among the logical variable. Okay. So you can see in the slide there are some example of the logical functions. For example, fx equal x is a logical function if x is a logical variable, or the fx equal negation of x. So it's also logical functions. and also the fx is equal x plus negation of x is also some kind of logical function, or fx equal x multiply negation of x. Of course, here the plus and the multiply the arithmetic should be defined. Here we not define yet, but this is a, you can see the one example of the logical functions. And, sorry bạn Đoàn Đức Cường, tôi sẽ tắt tiếng của bạn nha. And this is in the first example, you can only see that there is only one variable is x. But actually, the logical function can be the relation of the many logical variable. For example, here I put the function of two logical variable is fx1 x2 equal x1 plus x2, or f of x1 x2 equal x negation x1 multiply x2 plus x1 multiply negation x2. So you can have some imagination of the how we can present logical functions. Okay, so actually similar to 0 and 1, here in the logical function they also use some symbol like a plus or multiply, but it's we have to define it, and we also, and when we define it, then the meaning of this symbol is different from the normal algebra. Okay, so in order to establish the relations of many logical variable, so we go from the very beginning step is we build a very simple functions, and then we will make it more generous for the logical function. Okay, so we will define some basic logic operations, and from these basic operations we can expand to create the more complicated relations, and we call that is a complicated logical function. So actually for the basic logic operations is only have three logic operation. First is negations, second is disjunction, and third is conjunctions. All other logic operation you know is established from these three basic logic operations. So here I only present the three basic logic operations. So in order to define logic operations, one very common way is to list all the possible cases that can happen with this operation and the corresponding result, and then we can have the definitions of the operation. Like in the ordinary algebra, when we define the plus or the multiply operation, we just list all. Okay, so like in the elementary school in second grade, you study something like bảng cửu chương, right? It's the list of all the possibility that can be happen from 1 to 9. Then we have the definition of the multiply, and then we extend how to multiply of the two value with the number is bigger and bigger. So here in the Boolean algebra, we also do something like that. We make the definitions by list on the possible cases that can be appear. Okay, so first about the negations. So we list a value table. So if x is a logical variable, then x can only acquire two values, 1 or 0. So the negation of x is x bar. Okay, x bar is defined as follows. If x equal 1, then negation of x is 0. And x equals 0 and negation of x is equal 1. So this is the definition of the negation. Okay, so everybody already know. In Vietnamese we call x đảo hoặc là gì phủ định của x. Okay? So actually I will not talk too much about another thing, but for the expressions in the circuit diagram, they use a symbol here. Okay, so this is the symbol of the negations. The input is x and the output is negation of x. And please remember, it has the small ring here. So the small ring here in the symbol of circuit diagram is normally represent for the negation. Here also the negation, there are two, x and negation of x. Okay, so this is for the one variable logic operation called negation. So next about the disjunctions. Okay. The disjunction, or sometimes we call it logical plus. Okay. So the disjunction is defined with two logical variables. So here we have the two logic variable x and y, and the disjunction is write down like x plus y, and this is logical plus. And similar to the negation, we also use a value table to define the disjunction functions. With two variables, x variable can obtain two values. Then for two variable, we have four cases. Okay. The first case is both variable is equal 0. The second and the third case is one the variable equal 0, the others equal 1, and the last case is all the variable equal 1. It's a logical value, and the disjunction is defined like this. So x0 is 0, then disjunction of x and y is 0. Is x0 y is 1 or x1 y is 0, then the result is 1. And if both of them is 1, and the disjunction is 1. So this is the definitions of the disjunctions of two variables. So please remember, for the disjunction, the disjunctions of two variables only equals 0 when all of variable is 0. Okay, so actually it can be extended later. I will talk about extension. It can be extend to the function to the disjunction of the more than two variable, and the result is if at least one variable equals 1, then the disjunction is always 1. The disjunction is only equal 0 when all of the variables is equal 0. Okay. And for the expression in the circuit diagram, we also have two types of symbol. So the left side is like this. I don't know how to call this in English. In Vietnamese, it's like a trang khuyết, đúng không? So we have the x and y is input and the output is x plus y. Or we can use the square with the symbol larger or equal 1. Then we have x, y, and output is x plus y. Maybe someone will ask me, so how we use this symbol? So actually, if we use a symbol in the left side, so we use all the symbol in the left side. For example, if here we use this symbol, and then if we use a disjunction, we must use this symbol. Similarly, if we use all the symbol if we use a symbol in the right side, we have to use all the symbol in the right side. Thus I put in the slide. So, for example, if we use this symbol, then we must use this symbol for disjunction. Okay. Any questions so far?
Teacher.
Okay, so let's continue. I just talk alone and I feel a little bit like you talk with no one. Okay, and the next basic logical operations that I would like to introduce to you is the conjunctions, or the AND operator, or the multiply operator, logical multiply operator. And so we also define the conjunctions with two variables, x and y. And similar to the disjunctions, the value table also have 4 cases. So the first case is x and y equals 0, and the value of the conjunction is equal 0. The second is x and y, x equal 1, x equal 0, y equal 1, and then the conjunction is equal 0. The third case is x equal 1, y equals 0, and the conjunction is equal 0. And finally, both x and y equal 1, then the conjunction is equal 1. So we can make the conclusions. The conjunction of the two variables only equal 1 if all a variable equal 1. It will equal 0 if at least one variable equals 0. Okay, so this is a conjunction, or for simplicity, we call this a logic multiply. Okay, so actually this is the same with the normal algebra, but for the disjunction, okay, for the disjunction is not so normal, so this is the same with the normal algebra, the same, but here it's not the same because they don't have the value of 2 in the logical algebra. Okay, and this is expressions in the circuit diagram. This x and y is x multiply y, or x and y, and here is how to call this symbol in English. I forget this one, and x multiply y. So this is the expression in the circuit diagram. So I already review to use the basics logic operation, including negation, disjunction, and conjunctions. So these 3 operations create a whole world of the logic algebra or Boolean algebra. Okay, very simple but very useful. And next we will go to the basic law for the Boolean algebra. So the first basic law that I want to talk to you is the commutativity. The commutativity is x plus y equal y plus x, and x multiply y equal y multiply x. Or in other words, we can say we can replace 2 variables to each other, change the position with each other in the logical function with the conjunction and disjunctions operation. So actually this law is very simple, and someone may think, okay, this is obviously, why you have to say that? Okay, all of us know. So there are two things that make you benefit from this law, commutativity law. Okay. The first things is when help you if you write not in the order, right? The result is the same. So it's make you don't have the mistake. But actually, in many cases, the order is very important, right? For example, if you study about the linear algebra, the matrix, okay, the metric operation. So the metric operation don't have the multiply, metric multiply is not satisfy the commutativity law. Okay, so please remember, for the scalar system, for the logical system, the commutativity is satisfied. But for the matrix operation is not. It's totally different. Okay. Okay, so this is the first, and there are some story
related to the commutativity in the real world, in the education system in Vietnam, right? So there's a teacher. She asked the student to do the exercise. Okay, like there are 3 box, and in each box there's 4 apples, and she asked totally how many apples does you have, and actually I don't remember exactly the order, right? Maybe this must be 3 box multiply, or 4 apple multiply 3 box, and equal 12 apples, right? But the student did not do that. He wrote it like 4 apple multiply 3 box and equal 12 apples. And the student says, you are wrong. Okay? And the student, actually the teacher says the student was wrong. And when the student father checked the notebook, and they says, what happened with your teacher? You are right, but why this writes wrong? Okay, so the problem here is for the father, the commutativity is obviously, okay, so 3 multiply 4 or 4 multiply 3 is the same, the result is the same. But for the teacher, the order is very important, right? This is the logical idea behind the story. We have to, or we must obey the order. It's very important in the technologies, okay? And we have to understand the idea, the meaning behind the order. Okay? So this is the second benefit that's bring to you for the commutativity. Okay, so for the commutativity, the order is not so important, but remember, it's only if the commutativity property is this operation have the commutativity property. Otherwise, you must to obey the orders, the sequence. Okay, so it's very important. The commutativity, even it's very simple, and every people think that is so simple, right? I myself, when I was second of elementary school or secondary school, or especially in high school, I think this I don't understand much about this law. I think everything like obviously true. Why people have to consider this law? But for the mathematical, for the logical aspect, it must be consider this law. Otherwise, it cannot make the logical go. Okay, it's the first law. The second law is the associativity. Okay. So like x plus y plus this equals, we first make the disjunction of first 2 variable, and the result of this disjunction is also a logical variable, and then we make the disjunctions again between this result and this, okay, and the result is the same. Or another way, we merge the disjunction of the two last variables first, and the result also is a logical variable, and we make the disjunction with the first variable. Similarly, we can make the conjunction, right? So the associativity law is allow us to define the disjunctions and the conjunction of more than two variables. Okay. Please wait a moment. There's an emergency call. Okay. So sometimes there is some emergency call and I don't know what happened. Sorry. Just okay. So we go back to the basic law. We have the associativity. So I repeat again in this law, the associativity is allow us to define the disjunction and conjunction of more than two variables. Okay, disjunction. So it means that we can define the disjunction here is of three variables by separated to the disjunction of two variables and make it two times. Okay. First is x plus y, and this the result of this disjunction is also a variable, logical variable. Then we can make the disjunction of this result and this, similarly to the conjunction. Okay. And next is the rules distributivity. So we have the distributivity of conjunction over disjunctions. So x multiply y plus z equal x multiply y plus x multiply z. So this law is very common in the ordinary algebra. Tiếng Việt mình gọi là gì? Tính chất phân phối của phép nhân đối với phép cộng, hay nói khác là gì? Ta phá ngoặc đúng không? Okay. So this is very common and we can easily accept it without any proof. Okay. Of course we can prove it. I will ask you to do it later. But for the logical algebra, there is something is looks strange. X plus y multiply this equal x plus y multiply x plus this. Sorry, I will write down. I will make some revision here, so to make the similarity with this one. Okay, so just wait for a while. Okay, here it must be here. Okay. Look. Okay. Okay. So it's looks similar. So this is the distributivity of the disjunction over the conjunction. So we like x plus y multiply this equal x plus y multiply x plus this. Okay. So is there any questions here? Because it looks so strange. So the question here is this right or wrong? And how we can know is this right or wrong? Any idea, comment? So the first question is this right or wrong? Someone? So who says wrong? Raise a hand. Raise a hand in the team. No one. Okay. So when you said that is wrong, right? Or no? No one. For the okay, you have any comment? Okay.
For the second question of distributivity law, I see some wrong. Something
So
wrong.
You mean here, wrong?
Yep. Yep.
Okay. Okay, that I remember. I note your idea. Okay. In any opinion about this? No one. So everybody, other people feel that is true, nothing wrong. Or no comment? I don't, or you don't know?
I think in the distributivity, the second equation, the left side is in the simplest form. Can be expressed anymore.
I don't mention about this is simplest or not. I just mentioned is it true or not? Okay. So this is the first question, and we have some opinion that is not true. Second questions. How can we prove this law? How can we prove this law? Or how can we check if this law is right or wrong?
Teacher, I have the answer in the comment. Can you check my answer?
I saw it, but how to say? This is very basic or fundamental law, and you show the proof by using the fundamental law. This is not so how to say, it's like you use the distributivity property to prove the distributivity property. Do you understand what I mean? Okay, Mr. Chung, he showed the way he proved the distributivity property. It's not wrong, it's right, but something like use something you must to prove themselves. Ok, chỗ này mình chuyển sang tiếng Việt một chút, tức là bạn Trung với bạn có làm cái chứng minh ấy nhé, nhưng mà cái này thì không sai, thế nhưng mà nó trong cái tình huống này thì nó không hợp lý lắm, bởi vì là mình đang chứng minh cái tính chất phân phối ấy. Tính chất phân phối thì bạn Trung lại dùng đúng cái tính chất phân phối đó, đúng không? Bạn phá ngoặc bản chất là dùng tính chất phân phối mà, để mình chứng minh tính chất phân phối đấy thì nó không được hợp lý lắm, nhưng mà không sao. Yeah, so Mr. Xuân Tùng, he says we can prove it by listing the value and the result, right? So it is the most simplest way to prove one's law or another things by using the list, like a just table, or we list all the possibility, then we compare. If with the same combination, the result is the same for all the combination, then we can conclude that this true is right. Okay, so we just try this one. Okay. Here we will make one. Okay, we make this one, right? Then we will make the table x, y, this, y, this, x plus y, x plus this, left side, right side, and s case 1, 4. Okay. Okay, so it's the x, it's the y, this, and y and this, and x plus y, x plus this, and is the right side, left side, left and the right. So normally we will write the number of 0 and 1 so that when we change from the binary number to the decimal number, it will be increased. So like a 1, 0, 1, 2, 3, 4, 5, 6, 7. So here is 0, 0, 0. Okay, so 0, 0, 0, 1. Oh, sorry. 1, 1, 1, 1. And here is 0, 1, 1, 0, 0, 1, 1. And here 0, 1, 0, 1, 0, 1, and 0 and 1. And next is conjunction. Y and Z is 0, 0, 0, 1. Again 0, 0, 0, 1. Next is, okay, just. And next is 0, x plus y, 0, 0, 1, 1, and 1. Oh, sorry, 1, 1, 1, 1. Here is also 0, 1, 0, 1, and 1, 1, 1, 1. So the left side is equals this one and this one. Okay, we make some color. What color? Okay. Boom. Oh. Sorry, it's not so beautiful. Okay, so the left side is x plus yz, so 0, 0 is 0, 0, 0 is 0, 0, 0 is 0, 0, 1 is 1, and from the last four cases x equal 1, so all the result is 1. Okay, for the right side is x plus y multiply x plus this, so it's this one 0, 0, 0, 1, and here all is 1, so it's, oh sorry, this one is 1, 1, so it's 1. Here is 1, 1, 1, 1. So we can see that the left side and the right side is the same, the result is the same. So we can make the conclusion. This is a true, not wrong. And different from the normal algebra, for the Boolean algebra, we have the distributivity of the disjunction over conjunction. Okay. So it's very interesting. I like this. It's like a symmetrics. Okay. Actually, there is a property I will mention you later about this. So this is the three basic law for the Boolean algebra. Some other law, but it's not so interesting us much. But there is a law that's very interesting and useful for us. Is the De Morgan law. De Morgan law. We can conclude the De Morgan law as follows. The negation of disjunctions equal the conjunction of negation. Okay, and the negation of conjunction is equal to the disjunction of the negation. Okay. Nói tiếng Việt thì nó là gì? Phủ định của một tổng bằng tích các phủ định. Còn phủ định của một tích bằng tổng các phủ định. Okay. This is the De Morgan law. So I think De Morgan is very useful and very strong property for you, especially when you I think so. All of you already studied the design of the digital system, right? So in this subject, you have some exercise like we have a logical function, and you can only use one component like a NAND component to design these logical functions. And how can you design this logical function? Then you use the De Morgan law to modify the logical function, yeah, to another way. So during this law and property, I would like to say that for the logical functions, there is maybe many expressions of the one logical function. One choose table, we can use many ways to represent this choose table. Okay. So next, okay, I forget. So please remember the De Morgan law, and I would like to ask you the first exercise, homework. The first homework is prove the De Morgan law. Prove the De Morgan law. Okay? This is first homework today. Okay. First homework. Work 1. Prove the De Morgan law. Okay. Okay. Next, we go to another basics law that we usually meet during the we make the simplification of the logical function. So the first is disjunction of one variable with 0 is always equals this variable, and equally we have conjunction of one variable with 1 is always equal to this variable. Okay. The second, the disjunction of conjunction of one variable with 0 is always equal 0, and the disjunctions of one variable with 1 is always equal 1. The third law is the disjunction or the conjunction of one variable with itself is equal to itself. Okay, so remember x plus x is equal x, not equal to x. Okay, because we don't have the definition of 2 in the Boolean algebra, and x multiply x equal x, not x square, because we don't have the definition of square in Boolean algebra. Okay, the fourth law is the disjunction of one variable and its negation is always equal 1. And the conjunction of one variable with its negation is always equal 0. This is also very common, right? Because in this case, this junction, one variable between one variable and its negation, there have always a value of 1. So the disjunction is always 1. Similarly, between one variable and its negation, there is always a value of 0. So the conjunction is equal to 0 for all the variables. And the fifth law is x plus xy equal x, and x plus x multiply x plus y also equal x. Okay, this law is also look a little bit stranger in comparison with the normal algebra, right? So for normal algebra, so left side we have the x, right side we have the x, so x will disappear in both sides, and we obtain xy equals 0, and then we can conclude x equals 0 or y equals 0, right? This is the normal algebra. But here, remember, we don't have this because we don't define, we don't have the minus operation. So we cannot minus x in both sides. So this is it look a little bit stranger. Please remember. But prove it is easy, right? We make the distributivity, and then we can get x multiply 1 plus y. But 1 plus y is equal 1. So x multiply 1 equal x. Okay. This one is a little bit difficult, but we can easily. We can use the property of the distributivity. So to make here, so we can prove this. And the sixth basic law is here. X plus y, x multiply y plus x multiply y a bar equal x. This one also can be proved easily by make the distributivity is x multiply y plus y negations, and y plus y negation is equal 1, so x multiply 1 is equal x. And this one, x plus y multiply x plus y bar equal x. Okay, so this is a other basic law, and I want you to prove the fifth and the sixth law, the second. Okay, homework 2. This is simple. Okay, prove x multiply x plus y equal x. And x plus y multiply x plus y bar. Actually, if in case you cannot write down the bar, just plus tutor, okay, equal x. Please see the chat box, meeting chat, to see the homework, the second homework. Okay. And here I write down in the end of the slide, I write the duality law. Okay, this is one interesting property of logical function that other algebra have. So duality, for the Boolean algebra we have a duality property. So what is the duality property? So for example, we have this one here, x plus 0 equal x. So we can make the duality of this expression by changing disjunctions or plus by conjunctions or multiply in 0 by 1. So the second expression is called the duality of the first expression. And the property is that if the first expression is true, then the second expression also true. So this is a duality's property. Okay, so like let's see the second property, second law. X multiplies 0 equals 0. So the duality of this expression is x plus 1. Multiply is replaced by plus, 0 replaced by 1, 0 replaced by 1. Then we have the duality of the first expression is x plus 1 equal 1. Okay. And third is x plus x equal x. Then we change plus by multiply. So we have x multiply x equal x. And the fourth is x plus negation of x is equal 1. What we have the duality is x multiply x negations equal 1. Here change to 0. Okay. So in the fifth law, x plus x multiply y equal x, then we change plus by multiply, multiply by plus, and we have the same result. And also here, plus multiply replaced by plus, plus replaced by multiply, and multiply replaced by plus. Then we have x plus y multiply x plus y negation equal x. So this is a duality. And go back to the last slide. Here is also the duality. So I can plus is here is multiply plus in multiply plus multiply plus multiply plus multiply plus. Okay. So this one is very common, right? But make it the dual expression here is make stranger, but it's still true. Democrat law is also have the duality, right? So the duality law and other expressions show that in the Boolean algebra, the rows of negation are the row of disjunction and conjunction is the same. Okay, the equivalence for the normal algebra is not equivalence, but for the logic algebra is equivalence. Okay, so chỗ này tôi nói trong tiếng Việt một chút để các bạn nắm được. Tức là gì? Trong cái đại số logic nó có một cái khái niệm gọi là đối ngẫu, tính đối ngẫu. Nếu chúng ta có một hệ thức và chúng ta có thể tạo ra một hệ thức đối ngẫu bằng cách là thay thế phép cộng bằng phép nhân bằng phép cộng, số 0 bằng số 1, số 1 bằng số 0, đúng không? Ví dụ như ở đây, nhân bằng cộng, 0 bằng 1, 0 bằng 1, cộng bằng nhân, 0 bằng 1. Thế thì cái hệ thức dưới này gọi là hệ thức đối ngẫu của hệ thức trên. Và nếu như hệ thức trên này đúng thì hệ thức dưới cũng đúng. Và tính đấy gọi là tính đối ngẫu. Và tính đối ngẫu thì nó đúng với toàn bộ. Tất cả các thuộc tính mà tôi viết ở đây thì đều có tính đối ngẫu. Và cái tính đối ngẫu ấy nó cho chúng ta một cái thông tin rất là hay. Đó là gì? Đối với đại số logic thì phép cộng logic và phép nhân logic có vai trò tương đương nhau. Trong đại số thông thường chúng ta không có được cái đấy, đúng không? Đại số thông thường là phép cộng logic và phép nhân logic nó không tương đương nhau. Chính vì thế nên trong đại số logic thì chúng ta có tính chất phân phối của phép nhân đối với phép cộng và tính chất phân phối của phép cộng đối với phép nhân. Thế nhưng mà trong đại số thông thường thì chúng ta chỉ có một tính chất thôi, là tính chất phân phối của phép nhân đối với phép cộng thôi. Đấy. Tiếp theo thì chúng ta sẽ tìm hiểu một số cái cách thức mà chúng ta biểu diễn hàm logic. Okay. So we finish the definition of some operation, basic logic operation and some basic law and the duality property of the Boolean algebra. And next we will go to the next step to representation of the logical function. So there are many ways to present the logical functions. Okay. So the first first way to represent the logical function is we list all of the combination of the input and the corresponding result of the logical functions. For example, so this is very common. This is very common ways to describe or to represent a logical function, especially when we get the problem from the real world. Okay. So we usually present the logical functions by the choose table. Okay. So for the choose table, we try to list all the possible combination of the input, and we write down the corresponding value of the function, and then we can get the truth table. Okay, so this is the example of the truth table for 3 variable functions. Okay, so for the 3 input variable, we will have the 8 combination. 1, 2, 3, 4, 5, 6, 7, 8. And normally we usually write in order from the top to the bottom, the increasing the value of the number created by combine 3 variable. Okay, so in the binary it's 0, 0, 0, but in the decimal is 0. So next is 0, 0, 1, so in the decimal is 1. 0, 1, 0, in the decimal is 2. So we have 0, 1, 2, 3, 4, 5, 6, 7 here. And the corresponding outputs or the value of the function is right down here. Corresponding to x combination, we have the value here. Okay, so normally we will have for x combination there will be one values 1 or 0, but here you can see there is another symbol here in the result of the function is x here, here, and here. So why is x? X is called don't care term. Don't care term. What is a don't care term? Don't care term is mean that we don't care the value of the function for this combination. This one, and this one. It means that it can be 0 or it can be 1. We don't care. For example, to say, for example, when we do the examination. Okay. So if someone choose this is 1 and this is 1 and this is also 1, and he create a logical function, and other one choose all it's 0, and then this guy also create a logical function. So these two logical function is totally different, but these two guy is completely right. No one is wrong. Okay, it is meaning of the don't care term. We don't care the value. We just check if this combination satisfy, this combination satisfy, this combination satisfy, this combination satisfy, and this combination also satisfy. Then this function is right. We don't care the value of this combination. Ok, cái này thôi tôi nói lại tiếng Việt một chút cho nó rõ ràng. Tức là những cái chặng về nguyên tắc thì các cái hàm logic đầu ra nó chỉ có 2 giá trị 0 và 1 thôi. Nhưng mà trong một số trường hợp thì người ta có một trạng thái gọi là trạng thái không xác định. Mục tiêu trạng thái không xác định này là gì? Có nghĩa là gì? Ở vào cái tổ hợp đầu vào này thì đầu ra người ta không cần quan tâm. Nó là 0 cũng được, nó là 1 được. Đấy, đây là ý nghĩa của nó. Thế thì trong trường hợp các bạn sẽ hỏi, sau này các bạn sẽ bảo là thế trong trường hợp như thế thì em tổng hợp cái hàm logic như thế nào? Thì câu trả lời rất là đơn giản, bạn cứ cho đại các cái giá trị x này bằng 0 hoặc 1 tùy các bạn. Và bạn làm ra hàm logic. Và miễn là hàm logic đấy nó thỏa mãn các cái tổ hợp rõ ràng này, 10, 011 này đi, thì cái hàm logic của bạn luôn luôn đúng. Nha. Tất nhiên sau này sẽ có một khái niệm gọi là tối ưu hóa, tối thiểu hóa hàm logic. Thì bạn nên cho những cái ô không xác định này một giá trị 0 hoặc 1 nào đó để sao cho cái hàm logic của mình nó đơn giản nhất có thể. Nha. Nếu bạn làm được. Còn về mặt đúng sai thì nó không quan trọng. Okay? So in case you want to simplification of the logical function, you should choose the don't care term appropriately value of the don't care term, so that the logical function you obtain is the most simplest logical function. So it's a choose table. So the choose table is usually to represent the problem from the real world after we choose a logical variable and then we represent. The choose table is useful to understand the system, but not useful to implement the logical function. Okay. So we have to find another way to represent the logical function. Okay. The second logical function is the cardinal map. The cardinal map is quite complicated to explain. Okay, so we will try to go step by step from the simple case to the more complicated case. So the first example, we present the cardinal map for the two variable. So this is a choose table for the logical function. And in order to present this choose function table using the cardinal map, so we draw the 2D table, and for the horizontal value is one variable, and vertical value one variable, horizontal value is one variable, vertical is one variable. For example, for the vertical value is x1. So x1 can obtain two variables 0 and 1, and for x1 we use one line here. And first is for x1 equals 0, and second is x1 equal 1. And for x2 we use two columns. The first column is correspond to x2 equals 0, and the second column is correspond to x2 equal 1. So we, instead of write down x1 x2 here, we make a 2D table, and the one side is for x1 and one side is for x2. And for each combination of the inputs x1, x2 is correspond to one block here. And we write down the value of the function into these blocks. For example, x1 equal 1, x2 equal 0. x1 equal 1 is this one. x2 equal 0 is this one. So finally, this block is corresponding to the combination 0, 0, and we write down ones here. Similarly here, x1 equals 0, x2 equal 1. x1 equals 0 is here, and it must be in this row. x2 equal 1, here it must be in this column. Then we get this one equal 0 here. Okay, we have a short break and then we can continue later. Okay, 2:10 we go.
Okay, we go back to the class. Lớp hơi vắng nhỉ? Chém một hồi thấy ngủ vãn đi đâu hết rồi. Tuần sau điểm danh phát nhé, tuần này thôi. Okay, we go.
Em đưa thầy thì em tắt mic.
Okay, so I'm sorry, I mute and sao rồi bật mic lên lại mất một ông. Lớp bây giờ còn có 51 bạn. Okay, so the idea of the cardinal map is instead of you list all the combination as the truth table, we use a 2D table to describe the combination and the value of the logical function, and we divide the number of input variable into two groups, and the first group will be present for the row of the table, and the other group is for the column of the table. Okay, for example, we have the two input variable, then we divide to two groups. The first group is x1, and our group is x2. So x1 is corresponding to row, so we have the x1 can have two values, 0 and 1. Then we have two rows. So x2 is correspond to two columns, so we have two values, 0 and 1. So we have two columns. So finally we have the table with two rows and two columns, and the values of the function is filled into the block corresponding to the value of the combination. Okay, so it's the first two variable. For three variable, how can we do? For three variable, so we will separate into two parts, two groups. The first group is only x1 and corresponding to the row of the table. So we have one variable corresponding to two rows. The first row is x1 equals 0, and the second row is x1 equal 1. The second group is x2 and x3, because there are two variables. So, and we can only present in the 2D table. So for the column, we have to use two variables. For two variables, there are 4 columns. Okay, so we have 4 columns, but the numbering of column is have to to obey the rule of the cardinal map. So the rule of the cardinal map is two consequence row or column. Here is column. Two consequence column is only one bit difference. Okay, for example, this column is 0, 0. Then the next column is only one bit different with the first column. So it can only be 0, 1 or 1, 0. So here we choose 0, 1. So the first column is 0, 0. Then the second column is 0, 1. Okay. So the next column is also one bit different with
this one. So it can only be is 0, 1. So if one bit different, if this bit, so it's 0, 0 is this one. It's already have. So one bit different is can only 1, 1. So 1 become 0 become 1. So it's 1, 1. It cannot be 1, 0 because 0, 1, 2, 1, 0 is 2 bit different. Okay, so the next is must be 1, 1. And finally, is the 1, 1 is 1, 0. So finally, we have the columns that numbering according to kind of map is 0, 0, 0, 1, 1, 1, 1, 0. Okay, so we can call that these two numbers is go next to each other. 0, 1, 0, 0 and 0, 1 is next to each other. 0, 1 and 1, 1 is next to each other, and it must be next to each other in the kind of map. And 1, 1 and 1, 0 is also next to each other in the kind of map. And also even in the drawing of the table, we see that 0, 0 and 1, 0 is far from each other, but actually they also close next to each other because it's only one bit different, 0, 0 and 1, 0. So this is the difference between the cardinal map and the other way, in that you have to write the number corresponding to column or row according to the cardinal map rule. Okay. Ok, chỗ này tôi lại nói lại bằng tiếng Việt một chút cho nó rõ ràng, tức là đối với bảng các nô thì nguyên tắc cơ bản của bảng các nô là chúng ta phải gì? Vẽ sao cho các cái tổ hợp đấy nó chỉ cạnh nhau ấy. Nó chỉ khác nhau một bit thôi. Ví dụ đây là 00 thì tiếp theo phải là 01. Đó, hoặc là 10. Rồi đây là 01 rồi thì đây phải là 11 chứ không thể là 10 được. Tại vì hai thằng này là 0111 khác nhau cái bit thứ hai này thôi. Còn đây là 0110 thì bit thứ nhất cũng khác, một bit thứ hai cũng khác thì nó là sai luật ra. Vì vậy nên là gì? Nó phải theo một quy luật là hai ô cạnh nhau chỉ khác nhau một bit. Thì đấy là một điều quan trọng nhất ở trong bảng các nô. Và đây là bảng các nô ví dụ cho một cái gì? 3 bit. Đó. Thì những cái vạch đỏ này là chỉ là những cái vùng này, ví dụ ghi được vạch đỏ x1 cũng là cái vùng x1, tức cái hàng này x1 sẽ bằng 1. Cái vạch đỏ đây cũng là hai cái cột này x3 sẽ bằng 1. Vạch đỏ đây là hai cột này x2 sẽ bằng 1. Thế thì trong một số trường hợp ta không cần ghi những cái tổ hợp này ra để ta vẫn có thể khoanh các nô được dựa vào những vạch gạch này. Rồi. Next will be the example for the cardinal map of the four variable. So for the four variable, we have the 4 column and 4 rows because we divide the number of input variable into 2 groups and each group including 2 variable. So for 2 variable, we have 4 combination. So we have this one. And the way of numbering, the rule is the same. So we have 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Some people can make the numberings different, like a 0, 0, 1, 0, 1, 1, and 0, 1. It's okay. But please remember the area of each variable and the value of the logical function in each block. Okay. So this is a 4 variable. For 5 variable, we separate into 2 groups. The first group with 2 variable and the second group with 3 variable. With 2 variable, we already know. But for 3 variable, is a little bit complicated. So here is one kind of the example. 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, and 1, 0, 0. So the question here is how can we numbering the column here so that the rule is kept, right? If the rule is not kept, cannot be kept, then the using of kernel map will be give us the wrong value, the wrong result. So here I make the hint to you to write down how to write the numbering the kernel map. Okay, so here we just start from the most simpler way. Okay, for 2 column is easy, right? We just write 0 and 1. Okay. So for wait a moment, please. Okay. 0 and 1, right? So in order to write, to expand the result from the 2 column to the 4 column, we do the mirroring first. This is the mirror, and we make the mirroring. First is 1, it's mirror here, so it's 1. And 0 is mirror here, so it's a 0. And then for the first 2 blocks, we write in 0. We add 0 at the beginning. And the last 2 blocks, we add 1 to the beginning. So we can get the numbering of 4 blocks. Just follow the kernel map. Okay, 0, 0, 0, 1, 1, 1, 1, 0. So now we will expand this numbering rule to the 8 block like this. Okay, so the rule is also the same. For example, first we have 0 and 1. Okay, so as I said before, we can make the mirroring and 1 and 0, and then we add 0 as the first 2 block, 0, 0, and add 1 as the first 2 second block, 0, 1, and 1. Okay, now we extend this one to the 8 block. So we make this one is a mirror and make the mirroring, and here is 0, 1, 0, and 1, 1, and 0, 1, 0, 0, and then for the first half we add 0 at the beginning, 0, 0, 0, 0, and the second half we add 1, 1, 1, 1, and 1. So finally we can get the way to numbering the kernel map for the case of 8 block. Okay, This can guarantee that's the rule of the Kaggle map. Mọi người rõ chỗ này không nhỉ? Hello?
Có.
Nói lại một chút nhé, thực ra là gì? Mình viết ví dụ như là có 2 biến ấy thì mình viết là 01 rồi đúng không? Xong để mở rộng ra 4 biến thì mình lấy đối xứng với sang thì thành là 01 và 10. Xong đó nửa phía trước thì mình điền số 0 vào trước, nửa phía sau mình điền số 1 vào trước. Thì mình sẽ được là gì? 00011110 nhé. Thế xong từ 4 biến nếu mình mở rộng ra 8 biến thì mình cũng viết là gì? 00011110 trước. Xong mình lại lấy đối xứng trục đúng không? Là thành là 10110100. Thế xong nửa phía trước mình lại điền số 0, nửa phía sau mình lại điền số 1 thì mình sẽ được 8 cái ô mà theo luật Cardinal. Đảm bảo sẽ không sai. Ok. Thế đấy là cái phần Cardinal map. Thế thì the questions arise is how to write the Cardinal map with more than 5 variables. Okay, but I forget. Before we go to this, to answer this question, usually in scale of 5 variables, someone try to use a 3D table. Okay, 3D table. But in my point of view, I like the 2D. 3D is not so familiar. I'm not so familiar with the 3D, but you can do that with the 3D. But I think 2D is still okay. We still can see this, the 2D in scale of 5 variables. In scale of more than 5 variables, what should we do with the Kaggle map? To say the truth, people will not use Kaggle map for the case of the more than 5 variables. Okay, it's not convenient anymore for the Kaggle map. So usually Kaggle map is just for the up to 5 variable. It's not for 6 variable. It's a limitation of the Kaggle map. Kaggle map can be used very easily because it's like in front of us. We can easily see what we should collect, what we should combine, and so on. But it's kind of only convenient for the until 5 variable. For more than 5 variable, it's not convenient anymore. So usually, Kaggle map is only used for 5 variable. And in the examination, in the exercise, I only give you the question with up to 5 variable. Okay? Introduce to you another way to present the logic of functions, and this way is even more practical than function block diagram. So you already study the digital system design, right? And in these subjects, usually you use the block diagram to try to implement the logical function, and people use this like to make a chip, right? Nguyên khiển gì Nguyên? Trần Văn Nguyên. So usually people use this, and you make a chip, then you use a function block diagram. However, we have another way, and this way is older and is more convenient in some way, especially in industry, especially when we don't have the chip. Okay. So they call that is ladder diagram. So in order to present a logical function, people use a ladder diagram, and the main components of the ladder diagram is a relay. Okay, so I will introduce to you a ladder diagram that is used to present the logical function long time ago. Okay, before we have some kind of chip, some kind of PLC. Okay, before we go to the detail of the ladder diagram, just study some symbol, some devices, and that is be used to present the logical function. So as you may know, the logical function has two values, 0 and 1. So in order to present a logical variable, we choose some physical component that also have two states. Okay. So the very common device that have a two state is a button. Okay. So we have a button. So with the buttons, we have the action. We push the button. Okay, and the contact in the button will close or open. It depends on the type of button. So for the buttons, they have two types. Normally opens button and normally close button. And the symbol is here. Okay, so it's very simple. You can easily understand what is button. It's like an electrical button to switch the electricity devices in your home. Okay, so it's here like if you normally open is in the normal situation without any action. These two sides of the how to go is the side of the switch is separate with each other. Okay, so if you push the button, then this side and this side will contact with each other and the current can pass through. So the button, if in the like a no activate case is separate, then the course normally open. So in the normal is open. It's only closed when you push the button. So in the other way, we have the normally closed button. Okay, normally closed button is in the normal case is closed. Two side, two electrode is the contact with each other. If you push the button here, so the two electrodes will separate with each other. So we call that is normally closed. Without any action, two electrodes is connect with each other and the current can pass through. If you push the button, then two electrodes is separate and no current can pass through. It's separate, physically separate, mechanically separate. Okay. The second device is the limit switch. So the limit switch is one kind of sensor but it's only have two states. Is the open or close. Like a machine moving and the mechanism touch the limit switch, then the limit switch is closed. Then when the limit switch is closed, we know that there is some mechanism already touched through the limit switch, and we know that's the position. So the limit switch is one kind of sensor, position sensor, and they also have the two types, normally open, and we write NO, normally open, and normally closed, we write NC. Okay, so what is the difference with button and the limit switch? Actually, it's the same. It's also like a separate between the two electrodes, and it's some action. It's when change the state from close to open or from the open to close. Okay, but here people want to say the button is the action from the human, from the operator, and the limit switch is action by the machine or by the environment, not the human. Okay, is the difference. So like the action from the operator who want to control the system, we use a button. But during the working of the machine, there are some mechanism moving and touch, and we want to know the position using the limit switch. Then we use the limit switch. Okay, and the relays. The relay is the main component of the ladder diagram. So the relay. So did you study some subject like electrical component? Someone?
I think no.
No. Oh. Okay. So do you know about the relay?
Yes.
Did you know the principle of the relay?
Em nói tiếng Việt được không ạ?
Okay.
Nó được làm bằng hai cái thanh kim loại có độ dẫn ở với nhiệt khác nhau, thì khi nhiệt độ quá thì một thanh sẽ bật lên để khi rộng quá dòng thì nhiệt độ sẽ làm một cái thanh có độ dẫn ở với nhiệt thấp hơn, nó nảy lên làm ngắt dòng khỏi cái thiết bị đấy ạ.
Đây là cái em nói là relay nhiệt. Relay nói chung, ok, tôi sẽ giải thích một chút. Cái này tôi nói bằng tiếng Việt cho chúng ta dễ hiểu. Sau cái relay của chúng ta ấy, thì nó cấu tạo là gồm một cuộn dây. Cuộn dây đóng vai trò như cuộn hút, như cái nam châm điện ấy. Và có cái tiếp điểm. Tiếp điểm thường đóng và tiếp điểm thường mở. Được chưa? Thế thì cái relay ấy, nói một cách đơn giản, nó hoạt động theo nguyên tắc này. Khi chúng ta cấp điện cho cái cuộn dây đó, thì cuộn dây nó thành cái nam châm, và nam châm nên nó sẽ hút các cái tiếp điểm, nó làm cho thay đổi trạng thái tiếp điểm. Ví dụ như tiếp điểm đang mở thì nó hút cái thanh sắt ấy, thế là làm cho cái thanh sắt đấy nó nối hai cái tiếp điểm, hai cái cực của tiếp điểm đang mở nó đóng lại với nhau cho dòng điện chạy qua. Còn thằng bình thường nó đang đóng mà cuộn dây nó có điện một cái thì nó là hút, làm cho gì hai cái tiếp điểm đấy nó mở ra. Thế mọi người hiểu ý không? Mọi người hiểu cái nguyên tắc làm việc của relay không nhỉ?
Có.
Hiểu ạ.
Ok. Thế thì
đấy được gọi là relay điện đúng không ạ?
Relay điện, còn cái kia là relay nhiệt. Relay nhiệt tức là nó thay đổi trạng thái bằng gì? Bằng cái tác động về mặt nhiệt. Thì cái relay nhiệt thì hay được dùng để bảo vệ, ví dụ bảo vệ quá dòng ấy, tức là dòng nó lớn lên quá một cái, quá tải quá dòng ấy, thì là gì, cái nhiệt độ đấy nó nóng lên thì nó gây ra hiện tượng giãn nở về nhiệt, thì là hai cái tiết điểm nó rời nhau ra nha. Nhưng còn đây là relay này dùng để đóng cắt dòng điện. Và đây là với mục đích ở trong này là mình dùng để điều khiển logic. Thì nó ở relay nó có thể là relay trung gian thôi. Đấy, dùng để thực hiện các cái phép toán logic. Okay, so I hope all of you already understand the principle of the relay. Okay, so the relay including a coil and some contact. And the contact also there are two type contacts, normally open contact and normally closed contacts. So the principle of relay is when we supply a voltage for the coil, then the coils become an electrical mechanism, right? Magnet, something like that. And this magnet will apply the force to the contact so that the contact will change the state. Okay, so you can see here for the coil also there are two states. The electric is supply or not. And the contact also have two states in no close or open. So with these three devices, we can use to present a logical functions very easily because X devices also have two states. Is corresponding to two value of a logical variable or functions. Okay. So the principle is here. Principle is a ladder diagram. There are two poles of the power source as drawn as a vertical rays of a ladder. So wait for a moment, I will find the something draw. But okay, so I just make a brief introductions. So the ladder diagram is look like a ladder, right? So it has the two rays. Okay, we have the two rays here, two rays. Okay, so this two ray is corresponding to the power source. So actually we have the power source. Okay, for example, is a plus, is a minus. Okay, and we have some rungs, yeah, to show the button, the switch contact, the relay contact, or relay coil draw between two power rays. Okay, and we choose the appropriate device for X logic variable. So variable without the negation, we will draw the normally open type. And variable with negation, we will draw the normally closed types. For disjunction operation, we will make the two devices in parallel connection. With conjunctions operation, we will draw two devices in series connection. And the output variable will be the relay contact, relay coil. For example, if we want to write the Z's equal X plus Y, then withdraw. Okay. So I suppose it's a button. This, okay. This is X. Okay, it is X. And X plus Y. So for plus is disjunction. So it must be in parallel connection. In parallel connection. So it's a Y. So and we connect in parallel. And this is equal X plus Y. So equal, then this is output. So this must be a coil. And then we make the ladder diagram to represent the logical function. Okay, this way. So we have the example here. Y equal f of two variables x1 and x2 and equal x1 multiply x2 plus negation x1 multiply negation x2. So first we draw the x1 multiply x2. So we have x1 in series with x2. And because x1 and x2 is in normal case, it's not negation case, so the symbol must be normally open device, normally opens device. Second, x1 negation, so it must be normally closed button. x2 negation, it must be normally closed button. When it is a conjunction, okay, so it must be in series connection. In series connection, and this is a disjunction is in parallel connection. So we have this part is connecting in parallel with this part here, and this is output is will be the Y. It's a coil. So we can make the ladder diagram for the logic function. Okay, so please remember here x1 x1 x2 x2 because the negation is already represented by the normally closed button. So here x1 here is the name of the button. Okay, is one variable x1, one variable x2. You cannot write x1 negation here. It will be different. In the ladder diagram, the symbol, the name of variable is corresponding to the device. Different device is different name. Okay, same device, same name. Okay, so like a one button, maybe there is one button, but there are some many contact. It's very common because there is a button with many contact, many different type of contact, just for one button. Similarly, for the relay, we only have one name for the relay, and this name is used for both coil and the contact. So please remember. Ok, phần này mình sẽ nói lại một chút bằng tiếng Việt để các bạn dễ hiểu. Cái đoạn nối song song với mắc nối tiếp các bạn hiểu rồi đúng không nhỉ?
Thầy nói từ cái slide 22 được không ạ? Cái principle đấy ạ.
Được nha. Cái principle đây, nhìn vào đây nói lại thôi. Nguyên tắc là gì? Cái sơ đồ ladder hình thang là ladder diagram ấy, tức là giản đồ hình thang ấy, nó sẽ được cấu tạo là nó có hai cái đường hai bên này, hai đường hai bên này thì nó chính là gì? Nó chính là nguồn điện, đúng không? Một bên cực dương, cực âm đối với một chiều, một bên là ví dụ như là chân lửa với cả chân đất chẳng hạn, đối với xoay chiều. Thế và chúng ta có cái nấc thang này chúng ta sẽ nối. Thì nối theo nguyên tắc nào? Tức là ví dụ như cái hàm này, đúng không? Y bằng x1 x2 này, các hàm này là x1 x2 thì chúng ta sẽ dùng các phần tử, cái thiết bị ví dụ như là nút ấn hay là cái công tắc hành trình limit switch hay là cái tiếp điểm đô le để chúng ta biểu diễn nó. Thì ví dụ ở đây tôi dùng nút ấn chẳng hạn, thì x1 nhân x2. Thế thì nguyên tắc đấy là nguyên tắc thứ nhất. Nguyên tắc thứ hai là chúng ta sẽ mắc nối tiếp hoặc là mắc song song tùy thuộc vào cái hàm logic đấy là hàm nhân logic hay cộng logic. Và cái thứ ba là chúng ta sẽ dùng phần tử thường hay là phần tử đảo, phần tử là dạng thường đóng hay là thường mở, normally open or normally close, khi mà cái biểu diễn nó là dạng gì. Thì ví dụ ở đây ta sẽ lấy một ví dụ ở đây là chúng ta muốn biểu diễn hàm logic y bằng x1 x2 bằng x1 nhân x2 cộng với x1 đảo nhân x2 đảo, đúng không? Thì hãy xét cái số hạng đầu tiên. Số hạng đầu tiên là x1 nhân x2 và x1 và x2 đều ở trạng thái gì? Không đảo cả, đúng không? Thế nên là ta sẽ biểu diễn là x1 ở đây bằng gì? Bằng một tiếp điểm thường mở. x2 cũng bằng một tiếp điểm thường mở. Và hai thằng này nhân với nhau nên chúng ta sẽ biểu diễn bằng phép mắc nối tiếp là tiếp điểm x1 mắc nối với tiếp điểm x2. Tương tự như thế ta có là x1 đảo nhân với x2 đảo. Nhưng vì đây là x1 đảo, thế nên ở đây vẫn là x1 nhưng mà lại biểu diễn bằng tiếp điểm thường đóng. Tương tự như thế x2 cũng biểu diễn bằng tiếp điểm thường đóng. Đấy, chứ không phải là tiếp điểm thường mở. Tức là không phủ định thì là thường mở, phủ định thì là thường đóng, và nhân với nhau thì là mắc nối tiếp. Sau đó thì tôi có hai cụm này x1 nhân x2 cộng x1 đảo nhân x2 đảo, thì tức là gì? Mắc song song, tức là hai cụm này và hai cụm này mắc song song với nhau. Đấy là ta để cái cụm bên này. Còn đầu ra là y thì trong tất cả các trường hợp nhìn chung, đầu ra chúng ta sẽ chọn là cuộn dây của rơ le. Sau đó cái tiếp điểm của rơ le ấy, nó sẽ đi đóng cắt ở đâu thì nó đóng cắt. Được chưa? Đấy, ý nghĩa của nó là thế. Rồi. Thế thôi. Buổi hôm nay tạm dừng ở đây. Thì có thể các bạn cũng chưa thực sự hiểu lắm thì tôi sẽ ra một bài tập về nhà nữa và chúng ta sẽ chữa vào buổi sau. Ok.
Em thầy, em có một câu hỏi. Em thầy là mấy cái số ở kia nó có thể hiện cái gì không ạ?
Cái số ở đây nó thể hiện là điểm đấu. Tức là khi các bạn, ví dụ nhé, cái thằng x1 đây đúng không? Đều tên là x1 hết. Thế thì nó có hai nguyên tắc, hai cách. Thứ nhất là cái số ở đây nó thể hiện là cái điểm này sẽ là điểm cùng thế năng. Sau các bạn làm sơ đồ đấu dây trong thực tế, các bạn chỉ nhìn tất cả những thằng nào đầu 3, các bạn đánh dấu dây, tất cả thằng đầu 3 các bạn đấu lại với nhau là xong. Tất cả thằng nào đầu 7 đấu lại với nhau là xong. Tất cả thằng nào đầu 5 là đấu lại với nhau là xong. Hiểu không? Mình đánh số các cái tiếp điểm này thì xong cứ cùng số là đấu vào với nhau, thế chung. Đấy. Cái thứ hai là cái số này nó cho phép chúng ta gọi tên chính xác khi chúng ta phân tích sơ đồ. Ví dụ như bảo ấn nút x1 thì tiếp điểm x1 1 3 đóng lại. Chứ bây giờ bảo là tiếp điểm x1 thì nó có tỷ cái tiếp điểm ở trong cái sơ đồ này, chúng ta biết nói cái thằng nào. Nên là cái số này nó có hai tác dụng. Tác dụng thứ nhất là chúng ta định vị được cái tên thiết bị mà chúng ta định nói đến, tên cái tiếp điểm chúng ta định nói đến. Và cái tác dụng thứ hai là tác dụng trong cái sơ đồ đấu dây. Khi chúng ta làm tài liệu kỹ thuật, chúng ta thiết kế, nhưng thực ra cái này bây giờ ít rồi. Ngày xưa thì làm điện nhiều thế, nhưng mà nhìn chung là nó cũng thế, mạch điện cũng bao giờ đánh số. Tức đánh số ở đây thì tất cả những cái điểm mà có số giống nhau, có nghĩa là mình phải đấu với nhau. Đúng không? Chứ bây giờ mình ra cả cái tủ chi chít đồ, bây giờ mình biết đấu thằng nào với thằng nào. Thì bạn chỉ cứ mần là cứ thằng nào cùng số rồi mình đấu lại với nhau thế là xong. Chưa? Thì các bạn chú ý là x1 là x1 đảo đấy là trên hàm logic này. Nhưng mà trong cái sơ đồ này ấy, thì người ta sẽ không có x1 đảo nữa, tại vì đảo đã được thể hiện bằng tiếp điểm thường đóng rồi. Nên tất cả ở đây đều là x1 hết. Thế thì các bạn sẽ hỏi là có mỗi một cái nút ấn tại sao lắm chỗ thế? Dạ.
Những cái số này là mình tự đánh nha thầy, để phân biệt đúng không ạ?
Xin lỗi các bạn là trường Bách Khoa bị cắt điện. Mà may quá là chúng ta cũng kết thúc cái buổi học hôm nay rồi. Thế rồi thì cái tôi sẽ gõ cái bài tập về nhà ở đây, và có gì buổi sau chúng ta sẽ giảng lại cái phần này một chút nhá. Mọi người nghe được không nhỉ?
Đã có.
Ok, tôi sẽ gõ cái bài về nhà vào đây nhá. Là vẽ draw the ladder diagram for the function y equal function t equal m plus t multiply d negation. D tutorial là D negation nhé. Okay. So this is a third homework. Okay? Everything is clear?
Okay, but
Okay.
teacher, can you submit all the document of this course?
Okay, I forget. I will give you the slide.
I'm looking
Both in
for
Em thầy
Vietnamese.
là
some exercise.
gửi
The
bài tập về nhà đi.
exercise, the
Hay là ở đâu?
exercise is I already said in the class. I didn't write down anywhere. So please check in the chatting mock. For the homework, please make the homework here. Okay, go to the team and the file, and then make no, we don't have general and the file. There is a tài liệu lớp học recording, and you can make a new folder, homework, force 10, 20. Okay. So please submit the homework into this folder. And the name of the homework must be your name and your student ID. Okay?
Thầy ơi, trong cái bài tập thứ 3 ấy thì hai cái t nó có giống nhau không?
Là một, nó là biến t thôi, còn bạn nghĩ nào thì bạn cứ vẽ thế. Okay, let's think. And I will answer you the question. Answer you in the next class. So let's think and draw it. Okay? Okay, if there's no questions so far, I would like to stop our lectures today. Have a good week. Okay, so if you have any questions so far, please comment on the chat box and I will read it. Okay.
Như thầy ạ.
Bye bye.
Goodbye.